edition of the Times Techies webinar series. My name is Shilpa Fadnas and I have with me my colleague Sujit John. The two of us will moderate today's discussion. We hope you and your families are doing well and staying safe. Our discussion today is on embracing open source for software development. There's a huge increase in the number of applications that use software open source code, and that's fueling a massive wave of transformation. Tools like Kafka, Quarkus, and a lot more. To discuss this, we have two distinguished guests, Ameeta Roy and Vaibhav Jain from Red Hat. Welcome, Ameeta. Welcome, Vaibhav. Red Hat was at number 3 in the open source contributor index for May with 2,865 active contributors. OSCE looks for open source contributors on GitHub, the leading open source code repository for free and open source projects. Ameeta is Director of Solution Architecture at Red Hat India. She is responsible for providing technical leadership and direction to a team of solution architects that's engaged with clients and partners to bring the power of open source technologies to enterprises. Ameeta has been with Red Hat for a little over 2 years. Prior to that, she was with Oracle India, and prior to that with IBM for over 14 years. She's somehow back in IBM with Red Hat being acquired by IBM 2 years ago. Welcome, Ameeta.
Thank you, Shilpa.
We have with us Vaibhav Jain. Vaibhav is Associate Principal Specialist Solution Architect at Red Hat India. Vaibhav has over 18 years of experience in the areas of application, middleware, Devops, containers, cloud-native architectures, and production implementations. Vaibhav is currently responsible for working directly with clients for OpenShift and cloud-native related technologies. Welcome, Vaibhav.
Shilpa.
The two of us, we're going to moderate the session, and those who are viewing this can send in their comments through the Facebook comment box. Sujit and I will put them to Ameeta and Vaibhav. Let me start with Ameeta. There's a lot of discussion these days on companies embarking on digital transformation and application modernization. Where do you think that the industry is headed?
Yeah, so Shilpa, every company today is a software company in some manner, right? So modern enterprises today are finding that their markets are being dominated by digital engagement. So being competitive really requires that they embrace a software-driven business model. So whether that industry is telecom or banking or healthcare, you'll find that you're also a software company in some way. And apps, are at the center of it all in terms of a business strategy. So this software-driven business transformation requires that the new applications that are being developed have to be delivered faster, and it has to also be done to those end users who are expecting a higher quality. So what companies today are really doing is they're taking full advantage of the cloud computing model to be able to deliver business value. And today, because you have public clouds, you have private clouds, you have hybrid clouds, and you have these heterogeneous environments that are becoming increasingly prevalent. So cloud native application development as a means to quickly take advantage of and get all the benefits of a modern dynamic environment has actually become possible. So in previous Time Techies webinars, we had actually discussed about how a cloud native app can really be a collection of small, independent, and loosely coupled microservices, which are deployed in Linux containers, and then they're connected via application programming interfaces or APIs, as we call them, or it could be via a network of message routing. But every service today is implementing a business capability, and it is being developed increasingly by teams following a DevOps model. And we definitely see continuous integration, continuous deployment as a way of life, with most organizations to deal with this kind of continuous requirement to be agile as required by their business. And because of this microservices based architectures, they're able to also make sure that these services are being built quickly, deployed automatically, and they're updated regularly. And this is like far removed from your traditional monolithic kind of architectures. So definitely the adoption of containers, Kubernetes, and cloud native technologies is what we're seeing, increasingly seeing the uptake. And even I think in today's Times of India, there was an article that showed that DevOps and DevSecOps is also becoming a mainstream of choice, right, for building and delivering applications. So definitely, I would say containers and Kubernetes are at the heart and soul for such transformations as far as our experience goes.
And all of these are open source. Open source is central to all of this, is it?
Open source is absolutely central to all of these because they are giving enterprises the choice without vendor lock-in. So that leaves them free to actually deploy the way they want to develop, given their choice, without getting tied to any vendor-specific implementation.
So all of these traditional vendors, they're all moving to open source, are they? I mean, they're all taking on these.
There is definitely, at least I would say from the point of view of customers, in terms of the ones that are consuming, there is definitely a preference for open source because definitely there is a lot of innovation that's happening in the open source community, a lot of innovation, millions of projects which are contributing to several areas that we see today in the areas of IoT or AI ML or anything else that is the latest and the greatest that the industry is looking to adopt. You will find projects in the open source community. So there is a lot of choice, plethora of choices that customers have, and that's the reason I would say that there is increasingly a preference for open source.
Challenges from a developer point of view. What is it that we are hearing in the open source world? What are some of the problems that we are trying to solve?
Sure. Vaibhav, do you want to take that?
Yeah, sure. So in order to kind of understand what is the problem, I think we need to understand that why are we even talking about this, right? So first thing is we have been doing development for now decades, ages now, right? And with the time, technology evolves. The business demands are changing. The paradigm of the things, the way we kind of deliver the things are changing, right? The CI/CD approach, the DevOps approach we are talking about. Now, all this is possible with the help of the cloud, right? And that's where the cloud native architecture comes into the picture, right? So when we look from a cloud point of view, why do we feel that things change if we have to deploy our traditional application into the cloud? Because cloud is all about agility. Cloud is all about scale, right? Doing things at a rapid pace, at a minimum fraction of time. That's what we are trying to achieve. And at the same time, we are looking at the cost optimization, which means the big fat monolithic applications which we have developed so far, if we try to retrofit that into the cloud model, they may really not give us the benefit what we are looking at. So the tangible benefits what we are looking at, that will only come if our application is modernized to kind of consume all these benefits and then give you the output in terms of the business benefits, right? We are trying to get from these technologies. Now, that's where the challenges comes, okay? Because now when we're looking at the containers, when we are looking at the cloud, right? These are hyper-scale, not the traditional deployment, which means my application has to be very flexible, right? As a developer, when I'm developing my application, I cannot tell you that is it going to run in one container or is it going to run in 100 containers, which means I need to kind of think about it, that how I'm going to develop it differently. Then if I look at the cloud architecture, this is not new per se, right? Because when I'm saying 100 instances, it is more like a distributed architecture, which is again not new from an enterprise architecture point of view. Now, what is distributed architecture? Distributed architecture means that everything will happen over the network. So, and as a developer, I'm not worried because I haven't seen the production yet, right? So I simply assume that network is going to be there. And that's where the challenges comes. How will you know that out of 100 instances of application, 2 have failed and you need to stop sending your traffic to it, right? How can you bring the resiliency into the discussion, right? How can you kind of put certain checks and balances so that things can happen in an automated fashion, because we want less and less manual intervention among all this, right? That's where the challenges comes. Now, if I say, okay, I want these kind of things into my applications, how are we going to get them? So yes, we will go back and tell developers, you need to now code these 10 additional things for us. Is that going to help me over there? What I have seen in last 5-7 years, the unicorns of the business world, yes, they were able to do it. They were able to sustain it, but not everyone, right? And now with the help of this community, open source, the idea is that we should bring all the best of the world to everyone, right? That has to become a kind of common architecture for every other person. So that's where these latest frameworks comes into the picture, which are now being built keeping in mind the cloud native architectures, right? So that as a developer, I need not to develop those 10 additional things. Rather, I keep them as a configuration as a part of my application, right? So now you take the same application from a CI/CD approach, you deploy this across 7 environments, absolutely okay. Probably you want to now scale it to another cloud, right? That's where the hybrid cloud, multi-cloud architecture comes into the picture. Now, how that can be done without doing any changes into the code and just with the help of the configuration. Now, another part is the business needs are kind of increasing day by day. As a user, our experience, our expectation from the applications has gone up multifold, right? We don't see any application downtimes these days. We are not seeing any 500, 400 various type of errors which we used to see, right? So while this is changing now, every business, so that has become a baseline for every business, right? Now, how do you kind of incorporate all these capabilities in your application? And obviously with the reduced budget, faster timeline to deliver means a lot of more pressure on the developer, which means that we need to empower developers with the help of tools, technologies, frameworks. And that's where the open source community has been working very aggressively to bring all these aspects into the framework itself. So that when I am working, I am building my business logic to give you this beautiful functionality in our application, I am not worried about anything. I'm going to simply assume, I'm going to add certain dependencies, and voila, it's ready for use. And I'm not even worried, right, where it is going to get deployed. So yeah, that's what we are trying to solve.
Okay, so legacy Java applications that need to be modernized for new architectures, I mean, those kind of things, how do they work?
Right. So there are multiple things happening on that front, right? So let me start with the basic framework. The traditional Java Enterprise Edition, Java EE, which we have been knowing for so far. It has served well so far. It is still serving well so far. But going forward, when we look from a cloud point of view, we need thinner deployments. We don't need big fat deployment of the applications, right? We need small startup times. We need low memory footprint applications. Security has gone to a different level altogether, right? So how do we bring all these things? That's where the framework like Quarkus, are trying to help developers over here. Now, that's on the framework side. On the, let's say, stateful application, like I have got this beautiful business process, running into my application. And generally, I have seen enterprises using business process management, rule engine solutions, enterprise service bus, ESBs, using into their, application architectures. Now, these are kind of, big deployments, supposed to be a big fat centralized deployment, which is gonna serve you from a different touch points. But now that is changing with this architecture, because I'm not looking at having two different deployment. One is for the monolithic traditional, and then one is the cloud, and which cannot scale, because my backend is still stuck there. So again, on that front, there has to be some kind of innovation, and that's where the Cogito framework, right, which is K stands for the Kubernetes. So the BPM framework, which is natively developed on Kubernetes, first class citizen, can give you that scalability, even in case of the BPM frameworks, are going to help. Camel K from an integration point of view, right? Again, K stands for the Kubernetes. So ESB stands, but how do we convert that ESB into EIP, which is enterprise integration patterns, right? So you get the agility, right? That's the idea behind it.
Yeah, and just to add to what Vaibhav said, so when Java was originally designed, it was designed for those monolithic application stacks, right? Not for the cloud native modern applications that we see today. So if we look at a Java app as is the way it was originally designed, then it can be very slow when you start up, because it carries too much of a memory to be functional, especially when we're talking about newer and lightweight kind of frameworks. And normally what happens is some tasks will only take place when the applications are actually running, and they are performed in the memory. So what happens is you end up using excessive memory. So starting up these tasks itself takes a lot of time, and that makes the overall process not so efficient. So what Vaibhav talked about in terms of Quarkus, it can ensure that it performs this process very differently by actually calculating in advance how many resources are needed, And this ensures that the system knows what is needed, where, and how this application will behave. So then it can prepare all the necessary resources during the compilation time. So by default, then, less memory, is required, and then, tasks that are not needed need not be executed at all. So that makes it a lot easier now as a framework for Java developers to be able to, get quickly adapted to a new way of doing things, as Vaibhav was talking about.
Okay.
Right.
Okay, very interesting. Okay. Shilpa?
Yeah, we've already had some questions coming in. Do we take the questions?
Yeah, go ahead, Shilpa.
Sure.
Yeah.
Yeah, this question is from Akshay Bharadwaj. I'm going to pursue my BTech in CSE starting this year. What are the points we need to keep in mind to be industry ready with reference to open source?
Okay, so it's a very broad question, Akshay. But one thing, for sure will be, as I, and it's my favorite line where I say that, focus on the fundamentals. If you're, starting your career, while, technologies are evolving and we're finding better ways to do things, a lot of the fundamental principles do not change, So you need to, for example, Linux is gaining a lot of traction. So make sure that your Linux skills are very strong from an operating system standpoint, and then understanding conceptually, why. See, today we're talking about Kubernetes, we're talking about containers as an efficient way of doing things. And I'm sure, the industry will continue to evolve with newer frameworks, newer things coming to the picture as we try to fix, what is broken, what we can do better. So I would say, start with the fundamentals, get those strong, and, keep a keen eye out to keep yourself abreast with, the trends and of the technologies that are shaping the industry. And keep yourself updated, read a lot, and start getting yourself attached to some of these open source community projects, the ones that you're most passionate about. There are millions of projects, by the way. So, pick an area or a theme that you're passionate about, and then, you get a chance to start then seeing, how you can collaborate, how you can work in some of these open source communities, contribute to code, to bug fixes, and, whatever else. And then you will start, yourself start seeing the themes that will emerge and which areas you need to focus on. So sorry, I'm not able to give you a precise answer, but that is what I think you should focus on.
Yeah, we hear that from a lot of people. Yeah, just contribute to code. I mean, do it yourself as much as you can, even while you're in college. Shilpa?
Ameeta, we heard about event-driven architecture and serverless architectures. So what exactly does it mean for developers, and how do you think they can actually leverage the same?
Okay, so I'll try to explain what an event-driven architecture is. So basically, an event-driven architecture helps organizations have a flexible system that can adapt to changes and make decisions in real time, event-based. So real-time situational awareness, that means that business decisions, whether manual or automated, they can be made using all the available data that reflects what is the current state of their system. So an event, events, I should say, are captured from wherever the event sources are, right? And especially when we're talking a lot about IoT, Internet of Things, a lot of these sources could also be IoT devices, they could be applications, they could be networks, right? And there are always event producers and there are event consumers. So these event producers and consumers need to be able to share the status and what is the response information in real time. So organizations can add some kind of event-driven architecture to their systems and applications so that they can really figure out, what kind of scalability is required, what kind of responsiveness is required for their applications, and how they're going to access the data, and how they're going to look at the context of that event to be able to make a better decision. So, like I said, there are event producers, event consumers, and any event producer's job is only to detect those events and what does that event represent, and then, make sure that whoever, it may not know who the consumer of the event is, right? Or what is going to be the outcome of that. So when that event has been detected, then it is transmitted from the event producer to the event consumers through various channels. And then there might be some event processing platform that can look at it whether the event consumers need to be informed when it has occurred. Do they want to process the event, or maybe they are impacted by it? So that's how it is, when we talk about event-driven architecture. So typically an event processing platform will execute the correct response to an event and send the activity downstream to the right consumers. So, and sometimes, you use technologies like Apache Kafka, for example, in a distributed data streaming platform, which is quite a popular event processing choice. So it can handle, for example, the publishing, the subscribing, storing, processing of those event streams in real time. And then the other thing that you talked about, serverless, is also in some manner, could also be event driven, but it is a cloud computing model where the application developer doesn't have to worry about provisioning the servers or managing the scaling of their app. So all those tasks are abstracted by the cloud provider so that they can just push code to production much faster than in traditional models. And to talk more about what are some of these underlying technologies like Knative and others, maybe I'll request Vaibhav to add to this.
Yeah. So I'll just go back to the event-driven architecture, right? We were talking about Apache Kafka as the underlying layer to it. We call it as AMQ streams in Red Hat. See, it is all about building the real-time applications. And in my opinion, I think all the applications out there are real-time applications these days, right? Now, what is real-time application? You get something and you quickly want to respond to it. There could be a synchronous communication, there could be asynchronous communication, and there could be parallel processing. So parallel processing is like I am on an e-commerce website. I just add this particular product to my cart. The moment that happens, 5 different things needs to happen before I go for the checkout, right? My credit card needs to be charged. I need to go and check my inventory. My delivery needs to be updated. Shipping request needs to be created. In traditional architecture, how do? We generally go step by step. That's where the orchestration comes into the picture. But in case of the event-driven architecture, checkout is the event which has existed or which has been created now into my application. The moment that happens, parallelly 5 more things can be happening. Now, this is a flexible architecture again. Tomorrow, probably I want to add 2 more scenarios to it. Like I want to do fraud, analytics on top of it. I want to get more data from a marketing point of view, that what is the next offer probably which I want to show to him on the next page, right? So these are some advanced kind of things which I want to plug in into my application without touching the existing architecture. That's where the event architecture comes into the picture. It's more like an intelligent network within the application. I'll say not limited to just IoT or the one set of application, any application, right? All the applications are intelligent applications these days, which means that whatever is happening within the application, just like the spine in the human body, right? Whenever you get something happen in your body, all part automatically comes to one. They kind of react on automatically, right? Instantaneously, right? Some are kind of reactive, some are kind of proactive, right? So that's where the event-driven architecture comes into the picture. With the help of these components, again, we are extending this into, the imperative way, and I'll say in the traditional fashion as well as the reactive fashion too. Now, if we take this to a next step, because again, a new tool, new component could be a challenge for the developers to incorporate in your application. So what I'm going to do about it? That's where this Camel integration comes into the picture. The Quarkus comes into the picture. You need not to write, many things. What we are going to give you from a community project point of view, you will get the connectors. You have to simply put 1 line of code, just like the database connectivity, tell the source, tell the sync, it's going to happen automatically. And then the frameworks like change data capture, CDC are evolving. Now, we don't put the data from application to the database directly. It is being captured as a part of the event-driven stream. When the processing happens, everything gets scrutinized. Final data is being pushed from AMQ streams to your choice of database in an automated fashion. And that's where project like Devops comes into the picture, right? So many things are happening around this. But what I'm seeing is event-driven architecture is now becoming the de facto choice for any sort of application these days. And that's when people started talking about, again, if I link this back to my cloud discussion earlier, right? The serverless philosophy. Why are we talking about serverless? Because the intent is I should not pay for the compute if I'm not going to use it, right? Or how do I optimally use my resources? So let's say I have got 10 different functionalities in my application, but they are of no use until that event occurs, right? The moment that occurs, it should come, do its job, and go away. That's where the serverless helps me achieve certain tasks. So now serverless integration with AMQ streams out of the box gives you a better capability, better functionality, and less coding, obviously, on the developer front. But on the developer side, what it means that now I can build my application much effectively, can do better tasks inside my application from a business point of view, and can really create a wow effect. Because as a human being, when I am talking to any enterprise, I want to get recognized. I might be talking to them through 5 different channels, and that's where the digital transformation, digital experience comes into the picture. So how do Vaibhav gets recognized as a single identity irrespective of channel? And whatever I do on one application can also be kind of, reflected onto the other. That's the experience we are trying to kind of, give you with these technologies.
And I just like to add, the serverless part that, Vaibhav talked about, it's actually becoming instrumental with several companies that are looking at how they can achieve the goal of controlling the operational costs. And, this can become extremely important, right? So for example, if you look at the banking and FSI, they have to have some quote unquote always on processes, right? Which are running on some very heavyweight, run times like some, J2E application servers. And it can be consuming a lot of expensive memory. It requires a lot of servers to scale, and it needs to meet some very high availability kind of operational requirements. So quite often what used to happen was you used to have some permanent costs that were associated with reserving some CPUs and some memory. So with serverless, with auto scaling, what is happening is you're able to run a lot more workloads on your infrastructure, and it also allows the users to deploy multiple revisions of that entire application, so that they can actually look at how they can split the traffic and take care of loads. So really it is only as much as you need to use when you need to use is how serverless works. And beyond just the cost and performance, the other very important part is from the point of view of sustainability requirements, right? We're talking about carbon emissions and that kind of stuff. So definitely companies are investing in serverless to look at how they can diminish their energy consumption as well. And this is one area where serverless definitely comes to help.
Right. One more point to add, and the beauty of the solution is that it's not limited to just public cloud or the hosted cloud or just to the cloud providers, right? Now this all can be achieved at your choice of platform. It can be your bare metal, it could be your private data center, private deployment, any environment. We don't differentiate. So the idea is, if this is a beautiful functionality, you should be able to use it without being really dependent on one provider or one technology or one type of vendor person. Right.
Okay, so the event, the other day we had Big Basket's technology person on our show, on this webinar, and he said, yeah, the day the lockdown was announced, what some crazy surge it was on their platform, like 10 times or 30 times, I forget exactly what he said. But I guess these kind of architectures are crucial for these kind of events.
Absolutely. Because earlier you had to anticipate, right? You had to anticipate what might be the traffic, what could be the load, and you may have to provision the servers or those compute resources on the cloud or whatever in anticipation of what might be a peak capacity that might be required. But today, when we are talking about this way of doing things, it's letting developers focus on the code. They don't have to worry about setting up that complex infrastructure. And then what we are able to do is that you're able to create the service, you're packaging your code as a container image and handing it to the system. So what happens, your code will only run when it needs to. So a technology like Knative, which is the underlying one for the serverless that we are talking about, what it does is it starts and stops the instances automatically. So resources aren't consumed unless your code actually needs to do something, or unless there is an event that requires it to scale up. So therefore you're just paying for as much compute time as you're using and which means you don't have to anticipate also, right? You will be able to, be able to do that automatically via, this kind of a capability.
Okay. I have a question around serverless here from Vinay Kumar Kalagonda. How to track which service is consuming more time to process the requests when requests flow through multiple services, X serverless lambdas? I don't fully understand the question.
Yeah,
I'm sure you do.
Excellent question. Maybe I'll go first.
Yeah.
So I think the observability and monitoring becomes crucial when you talk from a microservices point of view. As I was saying earlier, microservices are nothing but a distributed architecture at a high level, right? So the question is that, probably I have 10 services being involved in one request. Now, how do I figure it out that out of 10, which one to blame? And how do I kind of correct it, right? In case of something goes wrong. And we also talk about cascading effect, right? If one service goes down, probably third one, the remaining 6 are also not going to get addressed, right? So which means my application or my request is going to fail. So how do I kind of take care of these things? Again, from a developer point of view, if I go maybe 3 years or 5 years back, developers had few libraries which they used to include in their application and manually used to kind of manage that, how I'm going to monitor this, how I'm going to, put the logic in case of a failure, how this needs to be treated, so on. Now, with the help of the container Kubernetes, and probably I'll extend this to another layer, which is called service mesh. There are multiple frameworks. Our choice of platform is Istio, which gives you this capability. Now, there are observability capability over there. With the help of Jaeger, you can do the open tracing. So it's like a sampling approach. You can figure it out of 10. Which one is taking more time, what are the hops, how much time exactly they took to process your request, and so on. So one is on the open tracing front. Second is from an observability point of view, service mesh gives you the capability to actually monitor the flow. So there are open source projects like Kiali, which gets integrated with Istio, which can actually help you to understand how your overall application is behaving. Now, we can actually go one step beyond this. We can configure our application in advance and tell our application that this is how you need to behave in case of the failure. Let's say my third particular component starts taking a lot of time because of this huge traffic, right? We were talking about. Now, my response time has gone beyond, let's say, 3 seconds, which is reaching my SL. What do I need to do? Obviously, I'm going to scale up, but certain times that is not possible because of various factors. So am I going to fail all the incoming requests? No, right? That's where service mesh can actually can help you to configure this at an infrastructure layer, where you can say, only this much of request per second is allowed on this particular component. Before you fail the request, please try 3 more times, right? Wait for 10 seconds. That kind of things can happen with this thing. Now, we are also talking about the chaos engineering these days, right? Chaos engineering is, how do I kind of test my application in advance? Because as Murphy's law, things are going to fail. Whatever can fail will fail probably one point of time. Now, how do we prepare ourselves for that? And that's where service mesh actually gives you much capability. This along with the container platform monitoring with the help of Prometheus, Grafana. You can also do the tracing. You can also use the logging capability with the help of, let's say, Elasticsearch, Fluentd, Kibana, and so on. So yeah, many things are there. Idea is that this should be part of the platform and not part of your development. Okay. So as a developer, I need not to worry. When I use Quarkus, I simply include certain, libraries into my configuration, where I will simply expose all the monitoring data by default. I will simply expose my health probe URLs by default, and then platform should be able to understand, configure them, monitor it, and report it back to you. And if needed, it can take corrective measures on your behalf, right? That's what we are talking about.
Absolutely.
Probably I take too many technology names, but
yeah, but fundamentally, if you look at it, service to service communication is actually what makes microservices possible, right? But the logic governing the communication, now you can always go and code it into each service, right? Without what Vaibhav talked about as service mesh layer. But just imagine, today we are talking about this whole communication getting a lot more complex, because we are having so many more containers. It's going to be a sprawl of containers, right? So that is where, as it becomes a lot more complex, the service mesh becomes very, very valuable. And when you're talking about your cloud native apps that are built into this whole microservices architecture, then service mesh becomes a way of looking at a large number of discrete services that are there across your enterprise, and how some of them can be grouped into a functional application. And then, of course, everything else that Vaibhav talked about in terms of the monitoring, the observability, the tracing, and everything else that the platform will take care of you today with all these open source technologies integrated in them.
This question from Jigar Pathak. Appreciate if you can share some light on Kubernetes operators. Thank you.
Okay, Vaibhav, I think you'll answer this better.
Again, great question. So operators, if I tell you the history, there used to be a company called CoreOS, which Red Hat acquired, and that's where the operator came into the picture. So what is operator? Operator, think like a vague example could be a doctor sitting inside the platform, which knows how to treat the platform, how to kind of rectify the problems internally. And in case tomorrow your application needs upgrade, your platform needs upgrade, anything is required, it can do that. So all the automation logic is sitting inside the platform itself. Now, the operators can be of two types. One is the platform operators, which basically deploys the container platform, manages the internal component on your behalf. So you need not to touch any configuration inside the platform, and can automatically do many things, on your behalf. Another thing is, when I am trying to deploy my application, can I make my application deployment intelligent enough so that it knows how to deploy this, how to upgrade this, in case, as we were talking about, something goes wrong, how to correct it, right? Maybe not from the point of view of a business application, but think from the point of view, let's say you want to deploy one database, right? Deployment of a database is a tricky job comparatively, right? Generally speaking. Now, tomorrow when you have to upgrade, there are certain procedures which I have seen people following before you actually go and upgrade it. Maybe you want to take the backup of it. Maybe you want to take some, additional steps. Some scripts are required in order to kind of making those API things compatible, data label changes and so on, right? Before you actually execute the upgrade, which means there is a manual intervention. There are manual steps which comes into the picture. Now, with the help of operator, what we can do, we can define all this as a part of the operator, which is a container or a pod, which runs inside the platform itself. So think like there is a operator which is running. Now, instead of you and manually going deploying the application, you tell the operator, hey, I want to deploy my application, and here is my application. This operator understands. It will pull the code, it will create a new pod, it will deploy the application, and it will manage and watch your application. Tomorrow there is a new version. I don't go and manually do the upgrade. I tell my operator that I want to now upgrade from version 11 to version 12. Operator understands because I have written the logic. Okay. So now when the version 12 comes, it automatically takes all those steps. It upgrades it to the version 12. Something fails, it rolls it back to the version 11, and always make sure that your application is always available, right? So this is what the operator we are talking about. Operator can be built using different, choices which exist as of today. You can do this in Golang, you can do this in Ansible, you can do this in Helm charts and so on. So the type of automation probably you want, you can have your choice over there.
Right. And there are operators that are there in the community that you can go and access and really try them out. And then there are a lot of certified operators that Red Hat has as a part of its operator hub, where we have a number of our own partner ecosystem that are developing. So there's a whole library that a lot of customers can actually choose from, that are verified by Red Hat OpenShift and backed by Red Hat and its partners. So there are the community ones, and there are the ones like I mentioned, which are certified by Red Hat as well.
Okay. We have some students in, looks like, an audience. Again, a question, you kind of answered it earlier, but still, anyway, I'm putting it to you. It's from Anushka Agarwal, asking, how can open source tools give me an edge over others if I'm appearing for campus placements today?
Anushka, open source tools are widely adopted across the industry, and that's the reason why it will give you an edge. because it's so wide and it's so rampant in its usage. Because even as recently as early this year, when Red Hat had launched a survey on the state of enterprise open source, right? In terms of looking at, talking to a number of industry influencers in terms of where they see the adoption of open source, there was an overwhelmingly large number that said that they have in some manner or the other either already adopted open source or are having it as part of their strategy. So there is a lot of scope, for you to be able to, thrive, because, like I said, there are millions of projects. There are lots of, companies that are part of steering committees that are, contributing to open source, including Red Hat. And, there are a lot of our customers, that would then also need to employ people with these skills, right? So, there's definitely a bright future, Anushka. Keep at it.
The college level, is it possible? I mean, what do you think at that level you can learn among the open source? I mean, containers, Kubernetes, are those things that you can learn in college itself?
Absolutely. Yes, you can.
Yeah.
So yeah, absolutely. You learn, like I said, right? Learn the fundamentals, learn, how, containers can be used. And containers, no matter what, like, let's say, for example, you're a data science student, right? And you are creating some of those ML models and, experimenting with some of those. Even those, we are talking today, about how we can, actually containerize and use some of these. So there is no a real, application area that is untouched in some manner or the other. So, it's never too early to start, I would say.
Okay. Things like Quarkus and all that, you learn at that stage, or you can come into it later?
If you're doing Java development, then you can definitely experiment, because, increasingly what is happening is traditionally the way we used to write code, at least if I have to go back and look back at the way I started learning to write code versus today, the way one can go about writing code, and Vaibhav, feel free to add. Today there are a lot of things that you can use in terms of ready configurations where you just have to kind of fill in the blanks kind of a thing, right? Rather than writing everything from scratch because of the frameworks that are available. So if there is a framework that can accelerate the way you go about doing your development, then by all means learn it, because we are working towards a low code kind of, progress that we're seeing in the industry, at least.
Vaibhav, you want to add?
Yeah, I feel we are living in the age where there is no age to learn these days, right? We keep learning, and everyone has to kind of keep up to it. So to that particular specific question, yeah, the early you start, I think you also, from a career point of view, try to figure it out that, which is the core area where you want to grow your career, right? Where your passion is basically you need to find out. And I think we can only get to know once we do our hands dirty. So I'll say go try as many as things you can at this point of time. I think that will give you much more clarity. And the early you start, the more wider perspective you gonna get. Now, getting involved into the open source technologies, learning all these things is becoming very easy these days, right? Now we are talking about better communication. You go and join Slack, you find so many communities, become part of it. I have seen many communities actually doing onboarding for the new joiners, right? Where they actually tell that how you can become part of the community, how you can contribute, what you can do. And then on a quarterly basis, they give you a kind of job over there where they will give you, let's say, one role for 1 quarter, and then probably another quarter, you will be doing something else. So that kind of makes you ready from a future point of view. And as Ameeta said, all these technologies are going to become the base. The way Java EE was the base for us 10, 15 years odd back, the concepts, the technology, the idea remains same. It is just that now we are talking about at a different level, right? So I'm sure with the robotic OS and so on, things are still going to be very much same, but yeah, very relevant as well. So Quarkus, containers, yeah, this is going to be mainstream, as I feel.
Okay. Shilpa?
There's a follow-up question from Jigar Pathak. Are operators and infra as code same?
Okay. I'll say yes and no. So infra as a code has a different philosophy about it. Okay. We Okay, so if I talk about infra as a code, the Ansible, the Git Ops comes into the picture. What is Git Ops? If I have to kind of explain, is whatever configurations you want to do into your infrastructure, you maintain a source code repository for all those configurations. Like in case of Kubernetes, all those YAML files, right? Your deployment configuration, your config maps, right? Whatever you're trying to configure, everything is stored into a source code repository, and they are versioned as well. So maybe I have 1.1, I have 1.2, and then in case of bug, I maybe go for 1.2.1 and so on, right? And whenever there is a change or there is a commit which happens into the source code repository, platform automatically gets to know, right? So it understands the changes, it pulls the changes, and it tries to apply those changes, right? That's where the infrastructure as a code kind of thing comes into the picture. Or maybe I want to provision a new one. I will simply pull the latest branch from my source code repository, which is the configurations, will apply onto my new clusters. And probably in 3, 5, 10 minutes, depending upon how much time it takes, you will have the exact replica, or rather the kind of state which you wanted to see from a deployment point of view. So that's the infrastructure as a code. As I explained earlier, operators is beyond this. So when it comes to deployment, yes, it will do the job. Operator and probably the infrastructure as a code, both, or GitOps rather, will do the same job. But when it comes to rectify things, upgrading and so on, right? That's more towards your application logic, the intelligence which is required to manage your application beyond the infrastructure. So operator helps you more over there. Yes, it can do infrastructure as a code, but that's the beginning, the step one. And from an operator point of view, the idea is if you go to the operatorhub.com, I think it has got 5 stages listed over there, right? And you can see which operator is at what level. So some can do the basic install, which is more like infrastructure as a code. Others can do, a version upgrade. They can do full life cycle management, right? All that kind of things can happen. So yeah, that's how they are different.
Okay, so in these days of distributed teams and remote working and all that, how do we empower developers? How can collaboration and DevOps happen seamlessly?
Yeah, that's an interesting question, and we've seen it acutely so in the last several months, right, where people have been working remotely and teams are distributed. So one of the areas that we have tried to make it easier is based on the open Eclipse project. So code ready workspaces is something that Red Hat has tried to bring so that these developers can actually use Kubernetes and containers. So that what we're trying to do via the code ready workspaces, which I said is based on the Eclipse project, is that we're trying to provide every member of the IT team a consistent, secure, and a zero configuration development environment, which means you can even set it up on your laptop. The experience is so fast and familiar, just like you get an IDE on your laptop. So what we do is we make sure that's included in OpenShift, so that's one way, and it's available in that operator hub that I was talking about, so that development teams get a faster and a reliable foundation, so that everything is centralized, the control is centralized, and it makes this whole DevOps a lot easier when teams are distributed. The other thing that we have tried to do is that the platform itself that we're trying to provide, right, to developers, we are making sure that this whole enterprise Kubernetes platform that we give on OpenShift, we make sure that it has all these capabilities pre-integrated, so that you don't have to worry about bringing this capability from the open source community or that one. We have got all those and got it pre-integrated along with whatever tools and frameworks that developers would need pre-integrated. So this makes it a seamless experience for developers to be able to work, because now when developers are using the same OpenShift platform, you're having the IT teams using the same OpenShift platform, then DevOps becomes a lot more seamless. And you can always bring in security into it as well. And a little while ago, I talked about data models that can also be brought in, so that you can really make, and I think Vaibhav talked a little earlier about the business process automation part, right? So now you're making that entire DevOps complete, right, from the business process automation that the developers have to do in terms of, developing the code that will help to automate some of those things, the security that has to come in, the provisioning that has to happen, everything becomes absolutely seamless. Vaibhav, maybe you can supplement that answer.
So, yeah, I think you captured it well, Ameeta. And if I extend this, when I used to be developer, I used to try a lot for the big fat development machines, right? My RAM is not enough, it is killing my CPU and so on, right? Now, how do we solve that problem? And that's where now the ID in the browser comes into the picture. So now we are talking about this development environment running inside a container on top of container platform. And when you do Control S, it spins a new container for you automatically. As a developer, do I need to learn anything? Absolutely no. Any traditional technology, any framework, because it is based on Eclipse, you can simply go and deploy it over there, right? So effectively what I need is just a browser interface, and using the browser, I access my development environment, I build my new code, I do a commit over there, I test the code. When I do the test, all the containers are automatically created, deployed over there. And as a infra guy, I am super happy because now I can give you the guarantee that this application is going to get into production just like that. From a security point of view, we talk about shift left architectures these days, where I'm telling you that all those things which needs to be checked, checking them at the last point of time used to be the older days, right? Now we want to detect them as early as possible. So how do I go beyond kind of the standard framework? How do I kind of incorporate it? How do I make sure that only the certified container images are being used? The library versions which we are using are vulnerability free and so on. Can I detect them early? Can I give that feedback early to my developers? Because we are talking about fail fast approach over here. So yes, all this in our overall philosophy. And then obviously this pandemic has shown us a lot, right? So we are talking about now working from home, right? Doing things virtually, remotely, but we need to effectively collaborate. Now we have got 5 team members, right, who are working on different modules, and we need to share our code multiple times, or we need to get connected to it, right? So how do we kind of bring that collaboration, which is again centralized, gives me all that capability, and now probably with a single click, I can go and execute my CI/CD pipeline so that it goes to the production in a matter of hours.
We have this question from Vishal Dhanure. How is the future looking for edge computing?
Okay, that's a good question. So today, considering that Industry 4.0 and the industry is expecting wide adoption, you have 5G coming. We're reading that in the news. So we definitely are talking. See, on one hand, we're saying distributed architecture, and now we are bringing other element of the edge devices also. All this while we were talking about bare metal servers, private clouds, public clouds, and now we are adding edge into the equation as well, right? So we are bringing computing capabilities closer to the edge, and then therefore we also need to then review our architectures, because data is growing, and instead of, like I mentioned, bringing the data over to your data center, we are bringing the computing capabilities closer to the edge, right? So all that, there are a lot of community projects. Again, we're seeing a lot of innovation happening in the open source community as well around some of the technologies and frameworks, and some of the aspects that we already talked about, in terms of all those open source technologies we talked about will be as relevant for the edge as they are to your traditional applications that are getting deployed out of your data center. That's what I would say. And definitely it's containers are going to be as relevant as ever. And then we just have to look at from the point of view of how much of data will actually travel between. That's something that one would have to factor in.
Okay.
I think in today's newspaper there was article Times of India, edge computing for the connected cars, right?
Yeah.
Underlines this.
Absolutely. Yeah. So the applications that are developed for the edge, I mean, those you're saying will use these very same technologies, is it?
They will use the very same technologies.
Okay.
The idea is that, right? The idea is that, but yeah, some tweaking is definitely required. But again, with the help of containers, because you get the guarantee of every or each deployment, and edge, we don't know how many edge sites, how many deployments. Some of them, even can go offline for a certain point of time. So how do they work in a disconnected? So a little bit complex architecture, another layer of the distributed architecture. But yes, if you use these technologies, it is certainly going to help you a lot.
Okay. I have a question here from Manish Agarwal. What kind of developers should use and can leverage the advantages of Apache Kafka? What kind of developers?
I think developers who work on integration technologies, I would think. What do you say?
Yeah. So if we are looking towards microservices, the intercommunication becomes very crucial. Now, how do you kind of build that, the orchestration layer, or the way you want to integrate your microservices? If you're going to kind of integrate them with the help of APIs internally, if it is a small application, probably you can do, but if it is a medium or large application, you will run into challenges, right? And over the period of time, with the API versions, with the data model changing and so on, things becomes complex, because in my practical experience, I have seen people running 200 versions of the APIs, right? Maybe not the best idea, but yeah, because other businesses are dependent on you, which means you cannot just remove that piece of code from your infrastructure, because there is a business which is happening, right? Now, in such environment, how will you make sure that your microservices communicate effectively? Only one version is talking to the relevant other version and so on, right? That's where the event-driven architecture comes into the picture. The flexibility which it can give you is not limited to, I'll say, any sort of application. I'll say any microservice, any cloud native application you are trying to deploy, go and definitely have a look at how this can particularly help. There are advanced use cases which you may not realize at the beginning of the project, but sometime down the line, you will definitely have those needs. You will need to have that flexibility in the architecture. And again, event-driven architecture will give you that flexibility.
Right. And wherever you need interoperability, which is definitely going to be a need of the hour as you work on these distributed architectures across heterogeneous environments, developers who work on those capabilities will typically be the ones that will need to use Kafka.
Another aspect is the parallel processing, right? Parallel processing is very important, because if you're looking for processing large data or doing some sort of real-time analysis on the data, that's where the parallel processing helps a lot. And I'll say, Kafka is definitely one of the leading component over there.
Okay. Traditional enterprises, what is the trend you see there? They also are generally going in for these kind of event-driven architectures and all that. Is it necessary for them? Some people who don't see too much of ups and downs and all that, it still makes sense for them?
Yeah, you're right. It will be relevant to the kind of events that their businesses need to respond to. The ones that have to be a lot more reactive, and that need to process certain things based on certain events and stuff like that, will feel the need more acutely than the ones that perhaps don't have such a dynamic kind of environment.
But what is it that you see in traditional enterprises? I mean, what kind of are they adopting these kind of technologies?
So that will depend on what do you define as a traditional enterprise. Okay. Yeah. So for example, like I said, right, FSI industry is definitely seeing the requirement. It could be, from an insurance kind of an application that may see so many requests, at some particular time of the year, when they need to purchase their insurance, or, and there may be some where that traffic is not so high. How many people may be buying insurance, let's say online on a, that can be something that can be factored, right? And some that may see, like the big basket that you talked about, the example that we see an unforeseen spike, right? So it depends entirely on how and what events this business needs to respond to in real time that will decide how they want to factor it into their architecture. And that is why quite often we say that business process becomes extremely important, where the business users have to be completely engaged in this whole process, in terms of defining, what is critical for the business, and then, what are some of those processes that they document, and then those become the criteria based on which the developers will, put in, the necessary architecture together.
Okay. Yeah, we are almost out of time. So any final comments, Ameeta, Vaibhav, that you want to make?
Well, I would just say that it's an exciting time for developers. There are a lot of things that are happening, that is making their lives a lot simpler than, the way, I guess, development used to be at one point of time, where, you had your defined set of requirements. It's a lot more dynamic, the environment. So today, the way we are seeing things is that no matter, what kind of application you're developing, right? We are trying to make sure that entire groups, teams are coming together seamlessly to work together on solving that problem. And developers are very centric to the entire thing. In fact, we call developers the kingmakers, because, they play a very critical role, because application agility is at the heart of, any business transformation, any digital transformation. How agile a business can be directly relates to, how quickly they can bring their services to market, how quickly their applications can be brought to market. And the ones who create those applications are the developers. So it's a very exciting time for developers. A lot of interesting things happening in the open source community that can be leveraged to build better applications that can scale, that can be flexible, and that meet the needs of the business without the developers having to worry about anything on the underlying, which means you can really enjoy writing your code without worrying about where it's going to be deployed, and which environment and things like that. So it's a great time to be a developer.
Okay, exciting time. Yeah, Shilpa, go on.
One last question, if I
Oh,
may.
there is?
This is from Saju Balakrishnan. Can you talk about future integration technologies?
Future integration technologies beyond what we talked about?
I think that's the question.
Anything
more about future integration technologies?
Right. So I think we already spoke about some, right? Event-driven architecture, the AN keystreams of the Kafka is obviously a piece of the integration. But a few other names which I took, like, change data capture, CDC, integration with your database or the traditional ERP solutions and so on. That's where the Devops comes into the picture, right? We are also talking about these days Camlets. Camlets is like, templates of the integration, right? So getting the data in and out, doing that data transformation and data enriching, data modeling can become a really complex job in certain cases. So how do I kind of provide you some efficiency over there? And that's where the Camlet comes into the picture. Camel K, we again discussed about it. So I think this is all kind of innovation which is happening in this area per se when it comes to the integration. And I definitely see a lot of enterprise integration patterns based deployment happening, because when we talk from a containers point of view, they have to be flexible so that they can go up and down, right? In fact, in my practical experience, I have seen if you deploy 100 integration touch points, 80-20 rule applies. So only 20% takes the 80% of the rule. So how do you make sure that only those 20% actually scales when the demand is there, right? Now, that's the kind of architecture we are looking at, because we really don't know how the requests are going to come in. We don't know who all business are going to be dependent on us and probably make us successful in the future, right? So that's the kind of flexibility we are looking at.
Okay. Exciting time for developers, like you said. Shilpa, you want to wind it up?
Yeah. Thank you, Ameeta and Vaibhav. We really learned a lot from both of you on open source technologies, and it's a great session. Thank you so much for joining us today.
Thank you. Yeah, thanks so much. I'm sure those who are listening would have learned a lot. Thanks so much.
Thanks for inviting us. Thank you, Sujit.
Yeah, our pleasure. Entirely our pleasure.
Thanks.
Yeah. Okay. Bye.
Bye.